In the last class, we have studied about the combination of the vectors. Now, we are interested to find the magnitude of resultant vector. So, here is mathematical method to finding the combination resultant vector of two vectors. Let we have two vectors A and B. We will combine them by using triangle law, so we can place the vector B along here. In this case, the resultant of both vectors will be given as R vector. Let the resultant vector R makes angle alpha with vector A, and the angle between A and B vector is theta. This is theta. Let these points are P, Q and S. Now, for finding the magnitude of resultant vector R, extend PQ and drop a perpendicular from point S. Now, in the triangle PMS, PS is hypotenuse, so PS square will be equal to PM square plus SM square. Since PM is a combination of PQ plus QM, so we can write this PQ plus QM whole square plus SM square, or we can open this PQ square plus QM square plus 2 PQ QM plus SM square. Now, we want to know the value of QM and SM. QM and SM. Since PQ is A vector and QS is B vector, and we can find that values. So here we don't know the value of QM and SM. So in triangle SMQ, the cos theta will be equal to base upon hypotenuse. So in this triangle, the base will be QM, hypotenuse will be QS. So QM will equal to QS cos theta, and we will give the name to the equation 1, and for this equation 2. And in same triangle SQ square equal to QM square plus SM square. So this will be equation 3. Now use equation 2 and 3 in equation 1, and what we get? QM square plus SM square. QM square plus SM square will be equal to SQ square. So this will be SM square plus 2 PQ, and this QM will be QS cos theta. QS cos theta. Now just simple write the value of this length PS, since PS is R, So this will be r square, pq will be value of a square, sm will be, sorry, we don't have sm, we have to write here sm plus qm square sq square. So this will be sq square, and sq have the value of b, so this will be b square plus 2ab cos theta, and this is our resultant vector r equal to under root of a square plus b square plus 2ab cos theta. This is also known as cosine law. This is also known as cosine law. And now we want to find the direction of the resultant vector r vector. For this, again, in the triangle PSM or PMS, for finding the direction we always use tan theta. So tan alpha will equal to perpendicular divided by base, and here the perpendicular is SM divided by base, the base is PM, or we can write this SM divided by PM is equal to PQ plus QM, PQ plus QM. And now again in triangle SQM or SMQ, we have sin theta equal to SM divided by SQ, or SM equal to SQ sin theta. Now use the value in this equation. SM we get tan alpha, SM will be equal to SQ sin theta divided by PQ, and this QM is equal to QS cos theta, so this will be QS cos theta. And now write the value, and we get tan alpha SQ is equal to B, so B sin theta divided by PQ is A plus B cos theta, or alpha equal to tan inverse B sin theta divided by A plus B cos theta. By using this equation we can find the direction of resultant vector r. Our next topic is resolution and component of vector. First we will find the component of a vector in two-dimensional coordinate system. For this, let we have a two-dimensional system of axis x and y, and in this two-dimensional system we have a vector OP of value r. For finding the component, we'll drop perpendicular from P on x-axis and y-axis. By this, we will get the x value and y value of the point P, and let the values are ax and ay, or let just x and y. Then in this case we can write this vector r vector equal to the magnitude of x plus the magnitude of y. Since this is vector, so we have to write this in term of magnitude plus and direction. So in x-axis the direction is I cap, and in y-axis the direction is j cap. So this will be our vector, and this r these are the component of vector r. This will be x component, this will be y component, and this can be written as r equal to rx vector plus r y vector. And if we want to find these values, let this is r y vector and this is r x vector. For finding this value, let our vector OP makes angle theta with axis OX. Then in this triangle ONP, we get cos theta equal to ON divided by OP, or ON equal to OP cos theta. Since ON is Rx, so Rx equal to OP cos theta, and OP is the R cos theta. So this is the x component of vector R, and for getting the y component we will take sin theta, which will be equal to Pn or Np. This is divided by OP, and we get Np equal to OP sin theta, which will equal to Ry equal to OP R sin theta, and this is our y component of the vector. So by this we get two components of the vector in two-dimensional coordinate system. Now we will find the component of the vector in three-dimensional coordinate system. Let we have a vector OP of value r vector. Then and this r vector makes angle alpha with x-axis, beta with y-axis, and gamma for z-axis with z-axis. Okay. Then in this case, for getting the value of component, we will draw perpendicular and draw a perpendicular on y-axis. By this we get this y component, and let this is our ry vector. And for getting the x component and y component, we drop a perpendicular here, and this will be in the plane of xz. And again from this point we drop perpendicular on x-axis and z-axis. By this we get this component rx and this component rz, and this r can be written as rx vector, ry vector plus rz vector, or we can simply write them x I cap plus y j cap plus z k cap. Now in this draw, this will be 90 degree, this is 90 degree, this is 90 degree. Since we have the vector making angles with all axes, in the previous case, as we have learned that if a vector makes angle theta with this axis, then along this axis we get the component cos theta, and perpendicular to this axis we get the component of sin theta. Okay, if we have an angle theta with this axis, then we get the component this cos theta, and this will be again now sine theta. So since here we have angle with all three axes, so here the x component Rx will equal to R cos alpha, Ry equal to R cos beta, and Rz equal to R cos gamma. If we square all these three equations and add them, then what we get? Rx square plus Ry square plus Rz square equal to R cos alpha square, R cos beta square, R cos gamma square. And since this is equal to R square, and here we get R square plus bracket cos square alpha plus cos square beta plus cos square gamma. This will be cancelled, so we get cos square alpha plus cos square beta plus cos square gamma equal to 1. Our next topic is product of vector. Vector can be multiplied by three types. Like the first is multiplication of vector with a scalar quantity. Let we have a vector r vector equal 3 I cap plus 2 j cap minus k cap, and we want to multiply this with a scalar quantity or just a number 3. Then what we get? 3r vector equal to 9 I cap plus 6 j cap minus 3 k cap. And what we are saying that our new vector r dash vector is just become 3 times of initial vector. So this is the multiplication of vector with a scalar number. Now in the second type, we have a multiplication of vector with a vector quantity. This can be further in two categories. Number first is scalar product or dot product, and the second one is vector product or cross product. In the first one, scalar product or dot product, by multiplication of two vector quantities, we get a scalar quantities. For this, let we have a vector A vector and B vector, and we want to make a dot product. Then the dot product of two vector will be given by the multiplication of magnitude of both vector and the cosine of the angle between both vector. Let we have vector A and B. This is A and this is B, and the angle between them is theta, and we want to multiply this by a scalar product or dot product. Then this can be written as A vector dot B vector equal to the product of both magnitude A, B and the cosine of the angle between them, which will be cos theta. And by doing this, we get a scalar quantity. For example, we have a work W, which is a scalar quantity, and this can be given as the dot product of force and the displacement D, or it can be written as FD cos theta. Now let's learn some properties of dot product. The first one is commutative law. The vector product follow commutative law. It means A dot B will be equal to B dot A. It means A dot B will be given by AB cos theta and B dot A will be given by BA cos theta. Since this is a scalar quantity, so if we change the sequence of A and B, there will no effect. And the second one, the dot product of two perpendicular vector, A vector and B vector. Since if A and B are at perpendicular, then theta will be 90 degree. In this case, A dot B will be equal to AB cos 90, and cos 90 have the value of 0, so we will get a 0. Next one is the dot product of two parallel vector. Let A vector is parallel to B vector. In this case, the angle theta will be 0 degree. So A dot B will equal to AB cos 0 degree. Cos 0 have value 1, so we get AB, which is the maximum value. Now next one is the dot product of a vector with itself. So we want to dot product of A with A vector. Since both are same vector, so angle between them will be 0. In this case, we get A multiplied by A cos 0 and we get A square. Fifth point is the dot product of unit vectors. I cap dot I cap, j cap dot j cap, k cap dot k cap. Since these are unit vector, so their magnitude will be 1. So 1 into 1, 1 into 1, 1 into 1. Both are same vector, so by this property angle will be 0, so cos 0 will be 1, so we get only the value 1. So I dot I equal j dot j equal k dot k equal 1, and I dot j, j dot k, k dot I. Since these unit vectors are I and j, I is along x-axis, j is along y-axis, k is along z-axis. All are mutually perpendicular, so between ij angle is 90 degree, between jk angle is 90 degree, between ki angle is 90 degree. So by the property of secant, we get the value of 0. So I dot j equal j dot k equal k dot I equal 0. Now the next property or the point is the dot product of two vector in term of their component. Let we have a vector A vector equal AX I cap, AY j cap, AZ k cap, and B vector is BX I cap, BY j cap, BZ k cap, and we want to find A dot B. Just write the value of A vector, AX I cap, AY j cap, AZ k cap, dot product of BX I cap, BY j cap, BZ k cap. Now if we multiply them, then what we get, AX multiplied with BX is give us AX BX. I cap dot I cap will give us 1, so this will be 1 and we don't have to write it. And the next one is if we multiply this, with j and k, what we get? Ax by, but I dot j will be 0, so there is no use of writing this. Ax bz I dot k will be 0. Again, ay into bx, ay bx, j dot I will equal to 0, and ay by, j dot j will be 1, and ay bz j dot k equal to 0. And now az bx k dot I equal to 0, az by k dot j equal to 0, az bz k dot k equal to 1. So this is our result. A dot b equal to ax bx plus ay by plus az bz. So if we want to dot product, then multiply the all component with same component, x with x, y with y, z with z. We have two types of multiply. First one is this and second one is this. So when between two vectors, magnitude of vectors and angle between them is given, then we will use this, and if the two vectors are given, then we will use this product.